Welcome back, everyone, and in the last video we saw the law of sines and the area formula associated to the law of sines. And again, these two formulas, laws, theorems, whatever, hold in any triangle, acute or obtuse or right. Okay, so now we want to put this to use, and we have a triangle ABC is where we have B, C, and C as given. Solve the triangle, and when we say solve, it means really find all missing angles and lengths. Okay, so what I'm going to do is I'm going to just set up a generic triangle, and I know that one side is 40, one side is 7, or 48 rather, and the other side is 70. And then, so if I label this is angle B, this is angle C, this is angle A, and then this is going to be side length C, which we know is 15. I need to find side length B, and I need to find side length A. Okay, so you can go ahead and determine angle A right away. If you do so, you end up with angle A as 62 degrees. Okay, so I would just maybe make a note here that angle A is 62 degrees, and how I found that is just 180 minus, so this is 180 minus 70 minus 48. Okay. Now I need to go ahead and find the other side lengths, and guess what? We need to use a nice fancy law of sines. So I'm going to do sine of B over side length B is equal to sine of C over side length C. And so the reason I do this is because I can easily put in, so B is 70, little b I do not know, sine of C, angle C is 48, and then this is 15, and then go ahead and solving, I get that B is 19. Now, again, also make sure that your calculator is in degrees. If it is in radians, you are going to mess up. So B is 19. Okay, I still need to find A, so let's do a similar setup. So I'm going to do sine of A. I'm going to do the ratio of that angle to its side length is equal to, and it really doesn't matter, but I like to use the known information, so I like to just continually go back to what I already know. So sine of 48, or sine of C over side length C, and then I can go back and fill these in. Okay, so this is 48 and this is 15, and similarly A is 62 degrees. Okay, and again, solving, we end up with about 17.8 after rounding. Okay, so there we go. We have all the missing pieces. Okay, so that's one example. I want you to pause the video and try this next one, making use of law of sines. Resume the video when you're ready to see the solution. And here is the answer. Okay, so now before going on, we can continue solving triangles so we're blue in the face, but technically we always have to have two rules that govern all the triangles that we'll ever work with. First thing is all angles have to sum to 180 degrees. That one's kind of a given. The next one that you may have forgotten about is that all triangles have to, or the side lengths in a triangle have to obey the triangle inequality. That is, that the sum of any two sides is greater than the third remaining side. So if we have, a triangle with side lengths A, B, C, we can do so we can do like A plus B, it has to be bigger than C, B plus C must be bigger than A, and A plus C must be greater than B. Okay, those have to be satisfied. Otherwise, if they don't, it doesn't quite work out. Okay, so we could, so we can do all these calculations, right? But at the end of the day, we need to make sure, okay, do all the angles sum to 180 degrees, and do these actually obey the triangle inequality? Okay, so you do need to double check your answers. Okay, so let's continue solving. Okay, and we can go back and verify number 1 and 2 for each of those other ones. I'm not going to take the time, but here we go. So we're beginning with the triangle ABC. Okay, I'm just drawing it like this. This may or may not be correct. We'll figure that out as we go. So we have 31 degrees, we have 3, we have 6.2, and so I need to figure out what C is, and I need to figure out these other angles. Okay. So let's go ahead and press on. So I'm going to do sine of 31 over 3 is equal to sine of A over 6.2. Okay, and so then I'm going to get sine, and then so if I do this, this is going to be sine of A, and if I completely isolate that, I get this. So, okay, then I can solve for A, right? I need to undo sine, so I do sine inverse to both sides. So A is going to be sine inverse of 1.064. And now, really, at this stage, there should be like red warning lights going off in your head. Okay? Sine, its output is between positive 1 and negative 1, right? So negative 1 to 1. We have a value that's more than 1. And when you do sine inverse, surely enough, what does your calculator spit out? A domain error. Okay, so this one is actually no triangle exists. So you can get like no solution. Okay. Now if we focus, so just be on the lookout for that. Okay, so make sure to just double check things, and I mean it is possible to get no triangle. Okay, next one, again I do a setup, just a generic one. It may be acute, it may be obtuse, I may need to change my drawing in a little bit. That's okay. 49 degrees, this is A, and we know its corresponding side length is 32. B, let's see, we normally go counterclockwise, so that's going to be here. This is 28, and this is C. Okay, so then I go ahead and just keep on solving. So we have sine of 49 over 32 is equal to sine of B over 28. Okay, and solving for sine of B, I get 0.66-ish. Okay, and then we can do sine inverse. So we get sine inverse of the 0.66 number, and with that I get approximately 41 degrees. Okay, now, okay, I'm going to keep that in mind, 41 degrees. Okay, and then I can find angle C, right? Just do the difference of those. So let's see, what do those add up to be? 90, if I'm not mistaken. Let's just double check on a calculator because I don't trust myself right now. 90, so then this should be 90. Ooh, drawing is really, really bad. Okay, but let's just check it. Okay, so let's just say, okay, I'm not quite sure about this. Let's see what law of sines would say. We'd say sine of 49 over 32 is equal to sine of 90 over sine length C, and sure enough, we do get a nice value here. This ends up being C is about 42.4. Okay, so it does work out, and we can certainly confirm by the triangle inequality if we were to do the sum of these two, that is bigger than this third one. If we were to do, 28 plus 42, that's bigger than 32, and then 32 plus 42 is certainly bigger than 28. So it does fit the triangle inequality, so it does seem to work, and all the angles do add up to 180 by construction. Okay, so everything seems to work out here. If you want, maybe try this one, and if you don't, we will in class. Okay, so let's say we have a triangle, so I'm going to do this as an extra problem to think about. I'm going to do this pictorially. So we have angle A, B, and C. A is 40 degrees, little a is 22, B is 25. I want you to determine, I want you to solve it. So figure out what these two angles are and what this side length is. Okay, so try and complete that, otherwise you'll be working on it in class.